when looking at your home system, you probably never really think about the USB devices plugged in because, in all likelihood, you're the one that plugged them in. Pretty much the only people that ever have access to the machine are you, whoever you live with, and any visitors. But usually, your visitors and who you live with are never touching the machine, so if something's not plugged in, either it's broken, your USB drivers are just doing something weird, or you unplugged it. That's pretty much the only thing you need to concern yourself with. Maybe, just maybe you're important enough, but you're probably not, that somebody is going to break into your house and specifically target your machine or hand you or someone you know a specifically crafted malicious device that you are gonna plug into your machine. That isn't necessarily true with devices used in public because sometimes there are people, if you leave a device unattended, who are gonna try to mess with it, who are gonna plug things in. Maybe not to specifically steal your data, but there have been cases of people walking around with USB killer devices that specifically exist to blow up your machine. But maybe you are somewhat important. Maybe you're a government official, you're an important person at some company, you're a military contractor, things like that. Maybe you're in an office around a lot of people, or maybe you're just some other person who is really important that people would do anything to compromise your machine. In those contexts, it is really important to know what is being plugged into your machine and ensuring only specific safe devices are being used. So recently I saw this patch sent up to the kernel. Patch version 2. I couldn't find patch version 1. I don't know if that version was ever submitted, or it had a different name. I don't know. From what I can tell, version 1 doesn't exist. HID, add malicious HID device detection driver. Basically, what it's trying to do is detect malicious USB devices. This series introduces HID OMG Detect, a passive HID monitor that scores potentially malicious keyboard-like USB devices, BadUSB/OMG style, using keystroke timing entropy, plug and type latency, USB descriptor fingerprinting. When the configurable threshold is crossed, the module emits a warning with a user space mitigation hint to USB guard, and things like that. The driver does not block, delay, or modify HID input events. If you don't know, BadUSB is sort of a catch-all term for malicious USB devices. So you're kind of used to normal devices. Like here is a random thumb drive. I plug it into my system. There is storage on the drive. I can access the storage, and that's all this does. If I plug in, I don't know, I've got a game controller here. It's going to allow me to use the input on the controller, and that is mapped to input on the machine. Same thing with a mouse, or I can plug in my smartwatch and it charges it, but also I can access the storage on the device. These are normal, sensible USB devices. However, not everything is going to be like that. You can have a device that pretends to be a keyboard and then installs something on your machine, for instance. So it shows up on your machine reporting as if it is a keyboard, but it is doing other things in the background. You can have something that mimics a charging cable, but is actually transferring data off of the device. You can have something that pretends to be a thumb drive, but then monitors your network traffic. All of these things are completely possible, and that's just surface level things you can do. If you specifically target an individual machine and know exactly what they are running, all manner of exploits are possible. It's hard to say exactly how long these devices have been around for. I would hazard to guess basically as long as there has been USB, but they've gained sort of mainstream popularity somewhere in the 2010s, and this is something that most people are at least somewhat aware of. If you're in the tech space, you have heard of the idea of a malicious USB as I mentioned before, there are things like the USB killer, which exist specifically to blow up a device. If you don't know how those work, basically what they do, and you can build devices that sort of mitigate this problem, but on cheaper devices, it will be a problem. Normally when you plug in a USB device, it's going to accept whatever voltage is given over that port. What they do instead is send really high voltage, usually pulsing, into the port and just blow up anything that is attached to it. There is specifically a way that things can be built to mitigate that, and it's a very cheap way to do it, but a lot of companies just do not include that hardware. USB killer devices are not as popular now that they've sort of become this, expected thing that exists and people kind of know about it. I'm not going to tell you where you can get them, but you can buy them online. Do not plug them into anything that you don't own, because you will break it. On this thread, there's not been that much in the way of feedback, and the main reason for that is, partially what was said by Greg Crower-Hartman. That's cute, but no need to get security kernel involved, as this is a new feature, not a bug triage. Also, why not do this as an eBPF program instead, as you have full access to the HID data stream there? Thanks, Greg KH. Basically, why are you even doing it in this way? There is a better and more sensible way to do this. eBPF, if you don't know, is the Extended Berkeley Packet Filter. The name, not very important. Basically, it is a way to run sandboxed kernel space code without having to go and, load new modules, modify the kernel code. Basically, it's just a way to run additional things in the kernel. And that's what Greg's saying here. Why do it in this way instead of using that method, which, at least from his perspective, would make far more sense for this kind of functionality? And Benjamin here has more to say on that. As Greg said, an HID BPF program would be far better in terms of scope because there are numerous pitfalls in your implementation. The question will be how to notify user space of the suspicious HID device in HID BPF. But here you are just emitting a demessage warning, so it's not doing much either. So the expectation is you're going to just throw out the warning, and something in user space is probably maybe gonna do something with that. But it's, as it currently stands, just something being thrown out with nothing actually being done with it. If this was accompanying some user space changes to actually make use of that, I think that would make quite a bit more sense. Following this long block of code here, he says, that's a strong assumption that actually depends on the report descriptor of the device, and what you said is generally true for USB keyboards, but not all HID devices behave like that. Bluetooth keyboards usually have a report ID in byte 0. Some devices are reporting gyro data, so they are sending a stream of events which would likely be tagged as suspicious, even though that is something it is specifically intended to do. This is the hard part about just generically detecting suspicious devices. There are cases of suspicious activity which would be normal in certain circumstances. For instance, actually a perfect example. You can make a Python keylogger in 5 lines of code, right? There are applications out there which are effectively keyloggers. They exist to log the keys you are pressing and then show them in like a bar or something else on your screen, which are useful for making videos and things like that. Now, in that case, that is not a suspicious application. You are specifically running it to do that functionality. But if some random script you download off the internet is doing the exact same thing, that then is suspicious. But how do you decide which of those behaviors is suspicious? In this case, if you have a stream of data, if that's gyro data, that's not suspicious. But if it's something else, it is suspicious. But how do you decide which of those is which? Some devices are reporting touch information, and as such, they are also reporting a constant stream of events as long as at least one finger is touching the sensor. Again, another case of a totally normal use. YubiKeys and other security keys and gaming devices are devices specifically tailored to send a stream of events being a keyboard macro or a one-time password or a stored password in the key. So you can have let's say I have these bindable buttons on the back of this 8-bit Do controller. I can bind one of these buttons to be a macro that constantly repeats some sort of binding. That is a totally normal thing to do, but it's not malicious. But if something else was doing that, like let's say you had a fake keyboard that was sending events and, trying to write out some commands, that would be malicious. Not all devices are keyboards. Also, very important point, there are USB devices that are not keyboards that also can be malicious. For example, like I said before, the middleman charging cable, things like that. Why restricting to bus USB only? Bluetooth could be a strong attack vector as well. That's another thing. You can have malicious Bluetooth devices. Not everything is a Bluetooth speaker that tells you it's turning on with a needlessly sultry voice.
Power on. Bluetooth mode.
In this part, a specific function was called. You can't call that function unless you are sure you are talking to a USB device. Because they are playing another, the transport driver is not USB HID, and you'll end up with a lot of issues. There is a function for checking if the transport is USB, HID is USB. Ouch, very much ouch. You are binding to any USB device, but you don't have implemented a match callback, meaning you are racing with any other driver to take ownership of a USB device. This is where your plan falls completely. There can only be one HID driver attached to a specific HID device, and we have multiple HID drivers in the subsystem. So either they get their fixes, the original HID driver, either they'll get the new security driver, but they cannot have both. And even worse, there is no guarantee one driver will be loaded before the other. Don't we love race conditions? So the main driver could be loaded, and then none of this security stuff is being done. Or this driver could be loaded, and then the security stuff is being done. Do you see why this approach may not have been the suggested way to do things? HID generic is a special case as this is a fallback driver, so HID generic is capable of unbinding itself to let device-specific drivers take over that device. But here that driver just takes ownership and can't release it, otherwise it's pointless. So definitely addressing that problem at the driver level is the wrong place. Either make it an HID core feature, but that'll be a harder sell in my opinion. Either make it a separate module that HID core calls in, slightly easy to sell but still hard, or work at the HID BPF level, much better because you need some user space eventually, and this way you can control from user space both the HID BPF program and your user space part. Even though it is clear they are trying to resolve a problem, in all likelihood, with the way this is being described, it's very unlikely this code is ever actually going to be merged into the kernel. That doesn't mean there isn't a problem here, just the approach being taken is certainly not the approach that's going to be accepted. But there are projects out there to guard against malicious USB devices. One of them was actually mentioned in the comments we just saw before. That is USB Guard. The USB Guard software framework helps to protect your computer against rogue USB devices, aka BadUSB, by implementing basic whitelisting and blacklisting capabilities based on device attributes. This also is a page over on the Arch Wiki if you like Arch Wiki formatted information. This is the kind of thing which most people don't really need to look at. But if you're in a situation where it's very important to know what devices are being run on your system, the most sensible thing to do is only whitelist very specific devices. The keyboard, the mouse, probably not even thumb drives. If you want to plug in a thumb drive, that should be done in a specific sandbox system that is detached from the rest of the network, and then take the data off of that. That is the safest way to handle things. Again, for you as a regular person though, it doesn't really matter. But if you want to go and maybe, I don't know, take your laptop into a cafe and you're worried about some random person doing something, this is certainly a step you can take. And there are projects related to USB Guard that you might say go even further. Things like Silk Guardian and USB Kill, which is different to USB Killer. This is one that you run yourself. It hasn't been updated in a long time, but basically, it waits for a change on your USB ports and then just shuts the system down. So if anything is plugged in, if anything is unplugged, something bad is happening, just end everything. For most people, that is way overkill. But if you're in a situation where knowing exactly what is plugged in and making sure that doesn't change is incredibly important, yeah, that is something that maybe you actually do want to consider. However, at the end of the day, software can be breached. You can work around software if you have critical information on a device. Let's say it's a laptop. Make sure it is never taken anywhere publicly. Make sure it is never connected to a non-verified network. And better yet, just don't have any access to the USB ports. So there are prison laptops, for example, and basically all of the USB ports are internal to the device. To plug in anything, it has to be plugged into an internal header, and you are not breaking into this machine without very specialized tooling. Now, people do it, and there's ways to get around it. There are some actually really good videos on these prison laptops, but that's the kind of device where it's hardware lockdown, and hardware lockdown is basically the only true safe way to do something. Do not let people have physical access to the box. If it is a desktop system and you want to make sure nothing is ever plugged into it, stick it in a box. Stick it in a box that you cannot get into, that needs a key to access it. That's the only true way to keep it safe. And people do exactly this. When we're talking about big data centers, it's not uncommon to have, like, server racks inside of a locked cabinet. That is a completely normal thing to do, and you also need to be sure about who has access to the room with the locked box, right? It's one thing to lock the box, but if then someone can break into the box, it doesn't matter if it's locked because they still got access to the box. Anyway, don't plug in random weird USB devices that you don't know what they are, and you're probably gonna be mostly fine. If you see a device on the ground, don't plug it into your machine, because probably gonna be fine. But sometimes people do drop things specifically to just get stupid people to have their machines be compromised. Easy solution, don't go outside. Anyway, yeah, I want to talk about malicious USB devices. Maybe I'll do more on that at some point in the future. I don't know, it's a fun topic, but that's it for now. So, if you liked the video, go like the video, go subscribe as well, and if you really like the video and you want to become one of these amazing people over here, check out the Patreon, subscribe, Daily Bearer Pay, linked in the description down below. I just realized my face has been kind of shiny for most of this video. It's a bit warm today. I'm gonna go, so I'm gonna get some lunch as well. It's also like 1 p.m. right now, and I haven't had anything to eat today. Bye-bye.